Section 2 of Louis Pasteur by Albert Keim and Louis Lumet, translated by Frederick Taber Cooper. This LibriVox recording is in the public domain. Recording by Pamela Nagami. Chapter 2. A Laborious and Enthusiastic Youth, Part 1. He was at this time a young man with a grave and meditative face, but under an apparent coldness he hid an ardent and enthusiastic heart, and an imagination ever on the alert. Louis Pasteur feared nothing from the dangers of Paris. His powerful strength of will protected him from pleasures which might otherwise have turned him from his path, and he was glad to realize how easily his passionate love of work enabled him to dispense with them. On arriving at the Pension Barbet, located in the Impasse des Feuillantines, he once more found Chapuis, the confidential friend and faithful companion of his leisure hours, and he mapped out his daily life in such a way as to extract a maximum of profit from the employment of his time. He roomed with a few comrades not far from the Pension, and his entire time was devoted to study. Too much of his time to suit Chapuis, who would have liked a greater proportion of amusement, and too much also to suit his father, who was anxious about his health. Louis Pasteur's habit was to rise in the morning at 5:30, for he had to tutor certain pupils of M. Barbet from 6 o'clock until 7, for he had been admitted to the Pension on payment of only 1/3 of the usual fee. Then he attended courses at the Lycée Saint Louis, went to the Sorbonne to hear the lectures of the famous chemist Dumas, who afforded him many a devout thrill when he spoke loftily of science and of the vast horizons that it opens to the human eye. He returned from these inspiring lessons trembling with emotion, burning with the desire to mark his own trail among those of his precursors, to be one of those who have raised a corner of the veil which hides nature's secrets from us. He was in such haste to learn, he felt such need of incessant work, that on the days of freedom, Thursdays and Sundays, he used to shut himself up in the libraries, and whenever he consented to take a walk with Chapuis, it was only on the condition that they should discuss as they walked some question of literature or philosophy. The young student's resources were very slender, in spite of the fact that the sympathy he had aroused in M. Barbet and the services he had rendered him had caused the latter to end by remitting the whole of the usual charge, yet he had sufficient to pay for his pleasures. At the urgent request of his father, he consented to go on certain Sundays to dine at the Palais Royal, where the sum he spent was scarcely ever more than 40 sous. And the crowning feature of this great treat was when Louis Pasteur allowed himself the luxury of the theatre, a thing which, by the way, occurred only 4 times during the whole period of his studies. It was in 1843 that he achieved the height of his ambitions. He entered the École Normale, the 4th in a good class, and he was so eager to breathe the air of the famous edifice that he cut short his vacation and presented himself several days before the date of opening. His type of mind, which was in certain respects monastic, accommodated itself to the system of the École Normale. His courage was redoubled, and he not only assimilated all the courses given, but already began to make certain private researches. He had a natural thirst for fame. He glowed with enthusiasm when he read the lives of illustrious men. He was kindled with the ambition to imitate them, but his preference leaned toward those who were benefactors and whose discoveries were useful to humanity. His father wrote to him to economize his strength, and he replied reassuring him, for the profound affection that he bore his family never wavered. But none the less he continued to work as hard as ever. Work, work, work was destined to be the maxim of his whole existence. While a student in the École Normale, Louis Pasteur continued to give lessons at the Pension Barbet, in recognition of the generous treatment he had received at the hands of its worthy master. He also continued to attend the lectures of Dumas, and followed him with absorbed attention, and to his great joy he was allowed to enter the laboratory of his instructor, Barruel, who gave him much practical advice. From this time forward the general development of Louis Pasteur seems to have been completed. His genius was revealed under a double character which was destined to assure the immortality of his works. He had an unlimited audacity of ideas. His intuitive conceptions soared to the outermost boundaries of human thought, and on the other hand, he bound himself down in his experiments to an extremely rigorous method that refused to take account of any fact that had not been strictly verified. While still a student, he already felt the need of proselytizing. He wanted to disseminate the science which he was acquiring at the cost of so much energy. So, in addition to tutoring the pupils at the Pension Barbet, he appointed himself professor to his own family, his father and sisters. He gave them problems to solve, he expounded scientific theories for their benefit, and he infused into all his correspondents the ardor of a young apostle. If they ill understood the significance of his problems, and if the explanations which he furnished seemed too difficult to be grasped by minds that did not have the advantage of a scientific training, he would encourage them affectionately and point out the high and noble necessity of constant effort. It was a debt of gratitude that he was gladly paying to his family, whose sacrifices had permitted him to obtain an education, and this touching role of the distinguished son and brother, giving instruction from a distance to his aged father and young sisters, reveals the bigness of his heart. After 3 years at the École Normale, Louis Pasteur passed his examinations for his degree in physical sciences in 1846. Out of 4 candidates, 4 were passed, among whom he stood third, with no special distinction. What was the young graduate going to do? Had he not now realized his most cherished wish in attaining the goal toward which he had striven with so much persistence? But during these years of study his ambition had shifted and broadened. To be sure, he still wished to be a professor and teach the sciences, but through contact with the masters of science and in the presence of the glory of their discoveries, he had become determined to distinguish himself in his turn by personal discoveries, almost as though he had a presentiment of his own high destiny. After he was graduated, it was not without anxiety that he realized that he might be sent to some provincial college, far from all the instruments essential to him. He was spared this misfortune through the interest which he had been able to inspire in his teachers, Dumas, Delafosse, and Balard, the last of whom took him as assistant in his laboratory. What at this time was the object of Louis Pasteur's researches? How was he going to approach the great problems of science? It seems as though a sort of predestination marked out his scientific career. Pasteur, who was destined to arrive finally at the vaccines of hydrophobia, began with the study of crystals, and his whole career was a sort of luminous ascension, progressing from the constitution of matter and its processes all the way to the transformation of microbes, the infinitely small yet most redoubtable enemies of man, into curative agents. Crystallography was then a new science with hesitant and controverted formulas. Essential phenomena remained without explanation, and others were still undiscovered, escaping all observation and all control. In order to judge adequately of the inspired novelty of Pasteur's discoveries, it is necessary to understand the state of this science at the moment when he began his work. In 1840, the men of science had only chaotic knowledge of the molecular structure of crystals. They knew the chemical molecule, writes M. Duclos, the great authority who was one of Pasteur's disciples. They knew that it is formed of an ordinarily fairly stable group of atoms, of which the number, the weight, and the nature may usually be clearly defined. They knew, for example, that there are one atom of chlorine and one atom of sodium in sea salt, one atom of calcium, one atom of carbon, and 3 atoms of oxygen in carbonate of lime. They had recognized that different composite molecules are ordinarily differentiated by the number and nature of their component atoms, but that nevertheless there are some which contain the same number of the same atoms without for that reason being identical, so that they were led to suspect that they differed in the arrangement of their atoms. What could be the relative disposition of these atoms one to another within the molecule, and what would be the resultant form of the molecule itself? All these were questions on which no one had any clear idea. Hauy, who had made a very special study of crystals and had named their constructive molecule the integrant molecule, considered that this latter had no relation to the chemical molecule, and that their different groupings were produced by molecules identically the same. Mitscherlich demonstrated that this theory was not absolutely exact, by replacing the atoms of calcium with atoms of magnesium in a crystallization of carbonate of lime without altering its form. This constituted the phenomenon of isomorphism. Delafosse, a pupil of Hauy and one of Pasteur's professors, was destined to study the phenomenon of hemihedrism, that by which certain crystals evade the law of symmetry and possess one facet which has no corresponding one, but he was unable to find the explanation. On the other hand, Biot had for a long time been investigating the rotary power of hemihedric crystals, and he had established that certain of them could deflect polarized light to the right and others to the left. This necessitates an explanation which we will borrow from M. Duclos. We all know, he writes, that every luminous impression is the result of a vibration accomplished after the fashion of a rigid rod, which, held in a vise at one of its extremities, vibrates at the other by oscillating around its position of equilibrium. Now, if at the movable extremity it has a polished button reflecting a point of light, we can make this point of light describe an ellipse, a circle, or a straight line. Let us examine this last case, which is the simplest, and let us agree to give the name of plane of polarization to the plane which contains the vibrating rod and the line of light described by its extremity. Let us suppose that this plane is vertical, and that the point of light is moving before us in line with the hands of a clock pointing to 6 o'clock. So long as there is nothing but the air intervening between the point of light and our eye, the vibration will not change its direction. But there are certain transparent substances which, when traversed by it, would turn it to the position of the hands of a clock pointing to 5 minutes to 5. If the substance passed through were of a given thickness, and to 10 minutes to 4 if it were double that thickness. In other terms, they cause the plane of polarization to rotate to the left to an extent proportionate to their thickness. We will call substances having the power of rotation to the left, left substances. There also exist certain right substances, for which, mutatis mutandis, the definition is the same. Young Louis Pasteur entered upon his work in the full midst of the evolution of the science of crystallography, which led from physics toward chemistry that was still full of unsolved problems. In pursuing the work required for the last of his university degrees, he tried to reconcile those personal studies that were dictated by his individual taste with those that were to give him the high title of Doctor of Science. he initiated himself into the practical manipulation of the laboratory, he trained himself in those infinitely delicate experiments which, if they were to be profitable and fruitful, demand calmness and unremitting attention. With a profound sense of realities, he recommenced, as a test of his own accuracy, the experiments of La Provoste in tartaric acid and the tartrates, seeking above all to learn whether by following the same procedure he would obtain the same results. For Louis Pasteur this was a period of intellectual fermentation, in which ideas flowed to his brain in extraordinary abundance, some of them perhaps still confused, but for the most part new and destined to open up unforeseen paths to science. On the 23rd of August, 1847, he defended his theses for the doctorate, which were piously dedicated to his father and mother, the one in chemistry, treating of researches into the capacity of saturation of arsenious acid, and forming a study of the arsenites of potash, sodium, and ammonia, and that in physics containing a study of the phenomena relating to the rotary polarization of liquids. Following his defence of these theses, which won him the degree of doctor, he took an extremely brief rest at Arbois, and it was with a sort of feverish impatience that he returned to Paris to continue his study of crystals. It was destined to continue for 5 years, and to end by shedding light upon what had hitherto been nothing but darkness and confusion. It is impossible to mention all the details and fluctuations of this research, for while great flashes of inspired intuition opened up new aspects of science, he verified them by so many experiments, rigorously conducted and frequently repeated, that a detailed account would mean a bulletin of his daily toil. In proportion as he obtained results, he addressed notes to the Academy of Sciences, the first dating from 1848, note on the crystallization of sulphur, researches into the different modes of grouping in sulphate of potash, researches in dimorphism, memorandum on the relation which may exist between crystalline form and chemical composition, and on the causes of rotary polarization. End of Section 2.